Yo, what's up guys, and this is my completed Redstone computer, but before I get into the video, I'm going to give you guys a quick demo of a program I wrote up. It's pretty simple. I give it two numbers in an operation, and it outputs the answer in hexadecimal. So if I were to start the program, and right now it is on 50 times speed, I can give it my first number, so we can give it maybe a 3-5 in hexadecimal, 3-5, and enter that, and then I give it a 0 for my operation for addition, so I can add them together. And then for my second number, I can give it 8 and 8. And so then this should come out to be BD. And so we can see it is working right now. And so it's starting to write to the screen. And almost there. There we go. Alright, so we have our answer is B and D. So let me explain how this works. So this is my Redstone computer. I have modified it slightly. As you can see here, we have a keyboard in these iron blocks. So there's a keyboard and just a basic 8-bit enter. So I can send in whatever signal I want into this blue over here, which is the input ports. So I've expanded the RAM. It is now 256 bytes instead of 128, and I'll explain why at the end of the video. And so we have our output, which is in green connected up to my screen. Now this computer has 256 instructions, like I said, 256 bytes of RAM. It has 8 registers, it has an 8 function, 3 flag ALU, it has an 8-byte stack, and an 8x8 character display attached to it. The computer takes around 4 seconds per instruction. It does not have a traditional clock like most modern computers do. So it's a little difficult to give it a specific hertz value, but it's around 4 to 5 seconds per instruction. But how does this work? How did I take two numbers and an operation, compute the result, and convert it to hexadecimal? Well, let me explain. So this is the code in my own assembly language that I use to program that program. So I labeled this out so that's a little easier to read, but we have these first 3 lines, which is simply just an input. The next one is simply just computing the result. So it moves the operation to the function register, and then it moves the two numbers I gave it into the ALU, and it computes the result and stores it. Then this outputs the A and S, which is just the answer, so just simply outputs the value for A, the value for N, and the value for S in their respective spots. Then this next code works on computing the first hexadecimal digit. This takes the top 4 bits and just simply shifts it down to the bottom 4 bits. And then next this just does some simple logic and determines whether the number is 9 or below or 10 or above, and depending on that it will turn it into the hexadecimal digit in the ASCII value system. Then it just outputs the first digit, and then it does basically the same thing. Then it gets the bottom 4 digits, or the second hexadecimal digit. Then it does literally the same logic to convert it to an actual ASCII hexadecimal digit. Then it outputs the second digit to the screen, and then this halts the program. Then I put this code through a compiler that converts the assembly into binary. After it becomes a binary file, I put it through some code that turns it into a Minecraft schematic. And this is from Matt Batwing's GitHub repository, so I'll link that in the description. But it basically just turns the binary file into a Minecraft schematic that I can then paste in using WorldEdit. So that makes coding this a lot more efficient. So that was just a really simple program I wrote for this. But I do have a big announcement. I have recently been working on a assembly compiler slash operating system for this computer, and so that's why I have my keyboard here, so I can actually type into my computer. It will display it up on the screen, and I can run different assembly operations line by line, kind of like a terminal. And why I expanded my memory is so that it can deal with files. So I actually made a kind of text editor almost, where I can load a file to the screen. I can select it by name, file 1, file 2, file 3, and load it to the screen, and then edit it and close it away, and it will still be saved in the memory. And so I'll be slowly releasing videos on it, so explaining the code, giving some demos of it, but that's for another day. If you guys have any more questions about my computer, feel free to ask in the comments, but that's all for now. Peace.